So 180 minus 38 is 142. That is the measure of angle 1. All right, the measure of angle 2. You should see that angle 2 is an exterior angle to this triangle. That means these two angles, these remote interior angles, if we add them up, should equal angle 2. So we are going to say that 41 plus 38, that's going to equal the measure of angle 2, which is 79 degrees. Okay, so that's 79. Which means the angle right next to angle 2 is 101 degrees. And that helps us find angle 3, because angle 3 is an exterior angle to this triangle. So these two remote interior angles, if we add them up, should equal angle 3. 46 plus 101 is 147 degrees. Am I going too fast? Let me know. Otherwise, I'll go faster. Okay, going fast enough. It goes a little bit slower. Okay. So the big thing here was exterior angles. Exterior angles are always equal to the two remote interior angles when you add them up. Always, always, always. That's the exterior angle theorem. Jump down to number 8. Okay, they tell us that these two sides are congruent, these two sides are congruent. Okay, so that's all we know about these two triangles. We have some congruent sides. And it says that the third side, AC, on this left triangle is greater than the length of PR. So this side is greater than this side. These two triangles obviously then are not congruent because one side is, the third side is longer than the other third side. But that does tell us something about this angle B. What does it tell us about angle B and angle Q? Yes, the measure of angle B is greater than the measure of angle Q, and that is by the hinge theorem. Hinge theorem is when you're comparing two triangles, and you know that two of the sides are congruent, and now you can compare the angles between those two sides, the included angle, based on how long the third side is. Or if you know how big the angles are, you know which of the third sides are bigger. So either way it works. So the hinge theorem and its converse are both true. All right, turn the page. So that means any problems I don't do, you do. So we have 8 pages to get through. We just got through the first one. Nicely done. Number 15. Optional. Do you need me to do number 15? It's exterior angle. I heard a few yeses. That's good enough for me. It's exterior angle theorem again. So this exterior angle is equal to these two angles added up. So there's your equation. And we will solve. That x looks a little bit hairy. So we found x. Okay. Next problem, directly below it. Also a problem I don't think you need me to do, but we'll move quickly through it. Class, angle 1. What's the measure of angle 1? 48 degrees, very good. Because these are vertical angles, very good. And now we should be able to figure out what angle 2 is because it's part of this triangle. So the triangle angle sum theorem says 3 angles of a triangle always add up to 180. So that's 108 right there, 60 plus 48. This must be. Okay, and that means angle 3 down here must be 70. Because 48 plus 62 is 110. So that means this must be 70 in order to add up to 180 degrees. Okay, decent speed? Okay, I will continue to ask you that, and you get to be honest, that's the important thing. Okay, number 26. We have to do 2 things. We have to do a reflection and a rotation to remind you about the different types of basic reflections. When you reflect across the x-axis, you change the sign of the y-coordinate, right? Just the sign changes. When you reflect across the y, you change the sign of the x. When you reflect across the line y equals x, you get y comma x. And lastly, when you reflect across the line y equals negative x, you get negative y, negative x. So you just flip the two coordinates and you change their signs. Okay, we're reflecting across the line, the x-axis. So negative 4 comma 2 becomes negative 4 comma negative 2. So there's b prime. And a is at negative 1 comma 5, so it becomes negative 1 comma negative 5. So that's our first transformation. We have to do 2. And the other one, stupid easy. It's rotation. We have to rotate counterclockwise 90 degrees. Remember, clockwise, clock says 12, 1, 2, 3, 4, 5. Clockwise is going this way. So counterclockwise will be going over here. 90 degrees, we're going to land over here. So you already know what your answer is going to be. It's going to be a positive x and a negative y. See that? So that'll help you eliminate your answer choices really quick. All right, I'm going to literally twist my paper 90 degrees and see where this lands. 90 degree twist. I see that A, double prime, is at 1, 2, 3, 1, 2, 3, 4, 5 over and 1 down. And B, double prime, is at 2 over and 4 down. So those are my new coordinates. So that would be B, I guess. Easy enough. All the other choices have negatives for their x values. Okay. Does that sit well? Not so much? Or is this meh? Okay, okay. Turn the page. Good news. That's a quarter of the pages done for today. Nicely done. Okay. We are doing number 30 next. Okay, so it says here, find the value of the variable and the length of GH, so it's a segment, if H, this point H, is between G and I. Okay, first thing we have to do, very first thing. Sorry, say again? Okay, we're drawing a picture. Picture drawn. G, let's see here, I and H. My young friends, be careful. The one thing that people make the biggest mistake on when they try to make this picture is they think that the word between means middle. It does not. So don't put H in the dead center. We don't know if it's in the middle or not. But don't confuse yourself. All right, let's see what values they've given us. They tell us here that the length of GI is 5b plus 2. And the length of HI is 4b minus 5. Okay. And it says that, they tell us that HI is also equal to 3. So that means that 4b minus 5 equals 3. It's the same length, right? Because they're both HI. So transitive property. Substitution. Okay, I think we can solve for B then. There's our equation right there. Are we okay with it? Are we okay with how we came up with it? Saying these two quantities equal? Because they're both HI? Okay. So we have 4b minus 5 equals 3, solving for B. So now we know what B is. We can figure out, let's see, they want us to find GH. Well, we know how long HI is. We can figure out what GI is by substituting B into it. So 5 times 2 is 10, plus 2 is 12. So that's 12. So how long is GH? Well, GI is 12, but GH is 9 it is, says the German. It's a German word. Means no. Okay, so our answer is C. So D, I imagine, is what a lot of us would have put because we thought, we're just trying to find the length of the whole thing. We're not. Okay, we're going to jump over to number 37. Am I moving too fast? Heard a few, yes. Okay. I will keep the screen at this size, and hopefully that's good enough. Here it says, use the following statements to write a compound statement for the conjunction or disjunction, so or and. Then find its truth value. Okay, so we have a bunch of statements here. We need to combine statements and then see if the combined statement is a true or false statement. So to remind you, if you put ands in between things, then all of them have to be true in order for the whole thing to be true. If even one of them is false, the whole thing's false. It's like, I can say, oh, it's Tuesday, it's a beautiful sunny day outside, and I'm a scorpion. Is that a true statement? No, because the last part doesn't make sense, at least not in the context. That makes no sense whatsoever. If I say it's Tuesday, or it's a beautiful day outside, or I'm a scorpion, is that a true statement? Yeah, because part of it's true. It's good enough, right? We put those ors in there. As long as you meet one of them, you're good to go. All right, so here, this symbol is the and symbol. It means and. I want to notate that in case you've forgotten. So we have to do Q and R and see if that's a true or false statement. Q says a right angle measures 90 degrees. True or false?
Yes.
True. Okay, we have a true so far. R says 4 points are always coplanar. True or false? False. Remember the stool? It sits nicely on 3 legs, but with that 4th leg, it always wobbles, right? Because it's not sitting in the same plane. So that is a true and a false statement, which means overall it is false, right? Even part of it is false. The whole thing's false when it comes to ands. All right, then the next symbol is an or. Okay, so our options are either false or false, which would be a false statement. The other thing would be false or true, which would be a true statement. So this can go either way at this point. S. S is a decagon has 12 sides. True or false? How many sides does a decagon have? 10. That might throw some people off because they think the word December, like, oh, 10. December is the 12th month, though, isn't it? But shouldn't it be the 10th month? Yeah, it used to be. Is that weird? That's why our last few months are all number months, but they're all off by 2, aren't they? That's weird. September 7, October 8, November 9.
Isn't it because they added?
Yep, they added months. Some disputes. I think it was between Gregory. Yeah, I think it was during Pope Gregory when they revamped the calendar. I think that's when they did the adding. It might have been Julius Caesar. The Julian calendar came before that. I don't know. Talk to the social studies teachers. They might know. Okay, so false or false. Overall is false. So let's see here. That gets rid of true, true. So it's either A or B. Which one is it? Is it A? Or, oh, because I have to go and then or, right? Okay. And right there. Yep, so B is the correct answer. Thank you, though. It's okay. Good for you. Make the attempt. That's important. All right. Now, number 39. Dilations. So this is chapter 9 stuff. Dilating is like fractional distance. So we need to find a vector and then shrink it down or make it larger and then add that to our starting point, which is our center of dilation. First thing we should do, we should plot everything. So let's draw a picture. So here we are trying to find coordinates of the image after the dilation. So our triangle, here are the coordinates, and then we have to dilate it by a scale factor of 1/5. So it's going to shrink. So draw a picture best you can. So we have our 3 points of our triangle. It doesn't specify a center of dilation, so what's the default? Origin, and it's the easiest thing to do is at the origin, guys. So everything starts with the center of dilation, everything when it comes to dilating stuff. So first of all, let's do L. L currently, to get to L from our center, is 5 units in the negative x, and then 5 units in the negative y. So my vector originally was negative 5, negative 5. We need to go 1/5 of that distance. So we're going to multiply that vector by 1/5. When we do so, our new vector is negative 1, comma, negative 1. So this tells me how far I have to move from the center of dilation. Well, my center is at 0, 0, so I'm going to add this to my center. Starting point and then marching order. So add those together and I get my new coordinate is negative 1, comma, negative 1. So that will be L prime. Okay, we're going to do that same thing again. We'll do it now for M. Let's plot L prime though. So there's L prime right there. M is negative 5 over and then 5 units up. So the original vector was negative 5, comma, positive 5. And multiply that scale by 1/5. So we get negative 1, comma, positive 1. And we're going to add that to our starting point of 0, comma, 0. So our new coordinate for M is negative 1, comma, 1. That's M prime. That'll be our image. My concern is that you are seeing this and going, oh, the vector is also the same as my final location. Why is that happening? Why is it that our vector, our scaled down vector, or scaled up vector, depending, why is it the same as the location we end up at? Yeah, because we're starting at 0, 0. So if we weren't starting at the origin, you'd have a different ending point, right? You wouldn't be adding 0 to it each time. You'd be adding some other number. So just keep aware. When you do go from the origin, yeah, it's nice and clean, and you see this kind of pattern show up. But if we're not going from the origin, it's not a huge change. You're just starting with different numbers. So instead of 0, 0, you'd add something else. Right, 2, 3, 5, 8, negative 1, 4, whatever. All right, so that is M prime. Last one. 5 over, negative 5 down to get to N. 5 over, negative 5 down. Scale that by 1/5. You get 1, comma, negative 1. If we add to that 0, 0, we get 1, comma, negative 1 for N prime. And those are our coordinates. Can you see that that triangle is about 1/5 the size of the original triangle in terms of its side lengths? It's been shrunk down. And can you see that it's gotten closer to that center of dilation? So everything is about the center. That's everything pivots around it. It's the nexus point. And for us in this particular problem, it was the origin. All right, doing well, I hope. Page turn. All right, 42. So here we're dealing with a dilation again. This time we're dilating about point A as our center of dilation though. This is different. We're not used to dilating about one of the points that are part of our figures. This is different. Rise up. I see some of you drooping. Rise up. I know, you're getting tired, especially since you haven't gotten enough sleep, I'm guessing, right? Mm-hmm, yeah. Okay, so A is our point of dilation. This is going to be easier than you think, guys. Help me out first of all. How far is it from A to D? What's the distance there? From negative 14 over to 10. 12 units? From negative 14 all the way to positive 10? 24? Okay, 24, is that what we're hearing? Okay, so you're saying it's 24 units. Okay, so 24 units all the way across. Okay, cool. This says that our scale factor is 0.25, so I don't need to go the full 24 units. I need to go a quarter of that. What's a quarter of 24? 6. So we're going to go over 6 units from A. So 6 units over from negative 14 would be negative 8. So this is now going to be D prime. Coincidentally, B is also 24 units straight up. So a quarter 24 there is also going to be 6 units. We are at negative 10, so 6 units up. We'll be here at negative 4. Not too bad, yeah? Not as bad as you thought it was going to be, not being at the origin. Of course, we're doing this graphically instead of algebraically now. And point C. Well, normally we had to go 24 units over and 24 units up. So our vector would be 24, 24. When we scale it down, what is our new vector going to be? 6, comma 6, right? So 6 units over, 6 units up. C prime. There it is. Can you see that that square is a quarter the size in terms of its side lengths compared to the original square? All right, and now you have all the coordinates, and you can easily write them down. And of course, we're missing one thing up there. Where's A prime at? It's the same as A, right? It hasn't moved. It stays right in the same spot. That happens sometimes in transformations. One of your points doesn't move at all, right? It stays fixed. That's okay. So this was easy enough. All right, with that being said, jump over to the other side. I'm doing 55. All right, so here we're doing a reflection across the line y equals x. We can do this graphically if you wish, but guys, you already have a mnemonic device that I rattled off earlier today, and rattled off before, months and months ago as well. We're reflecting these things across the line y equals x. What happens to our coordinates? They just switch, right? So what's J prime going to be? 5, comma. Very good. Could somebody else give me the next one, K prime? Mm-hmm. Next one, K prime. Okay, negative 5, comma 3. And L prime. Could somebody else, hasn't spoken yet, give me L prime? 4, comma 1. Hey, we're done. That's it. Easy enough? So that's why I taught you that device, so you don't have to spend the time drawing the picture. You can quickly find these things. All right. Okay.